All right, so why don't you just read the question I pasted at the top there and then ask me any questions and we can get started.
Okay, so given an integer number n, return the difference between the product of its digits and the sum of its digits. Yeah, no questions. I think I'm all set.
All right.
Oh, should I start?
Yeah. Just start with whatever you want to talk it out. Let's see, edge cases and all that stuff.
All right, cool. So given an integer n, return the difference between the numbers and the sum of its digits. So I'm going to start with an integer number n. We're in Python, so I do not need commas. Semicolons. And
Do you want to do C++ for this one? I can change it over.
I think I'm all set with Python. This should be good.
All right.
Return the difference between the sum of its digits. Okay, so the product of its digits. So we want edge cases, meaning that it could be a single digit or any number of digits. So for x in n. So to use the for x in n, we want to cast n to be a string, right? So that we can parse through it the way that we would if we were to say for x in n.
Yes, yeah. Okay. So the syntax for that, I'll just put at the top here, is just this here.
Oh, great. Okay, that is helpful. Okay, so we convert n to a string, then for x in n, meaning for each character in n, return the difference between the product of its digits and the sum of its digits. So we're going to find the product of its digits. So for all of x in n, we're going to multiply all of them. So let's get a product. Well, int product. I'm going to use this as our product variable, and as we go through n, we're going to use that to store the product of the digits. So for x in n, product equals product. I want to make this 1 just to initialize it. Product times x. That'll give us our product, and that should be all set for that. And then the sum of its digits, we could probably include the sum of its digits in the same for loop so that we don't have to make 2 separate for loops. So int sum equals 0. The sum of its digits, we're going to say sum equals sum plus x. And then we're going to return product, return sum. Actually, this looks like a reserved word, so I'm going to call it sum x.
Sure.
And
okay.
I feel like typically we return like a single phrase.
Right. So remember that we want to return the difference between the sum and the product.
Oh, right. Okay. So I'm going to say int results and equals. Well, we want to find out which one of these is bigger. So because we want to turn a positive. The product will probably be bigger.
Yeah, I was going to say the product should always be bigger here.
Yeah. So result equals product minus sum. And no semicolons.
All right.
Oh, do we have to pass this? Or you can just say return result, I think, right?
Yeah, so I was going to say, why don't you write a function definition for this, and then we can just tab everything over. So we write a function called like, difference or something like that.
Okay, so I'm going to call it define difference.
And then takes in n.
Okay, n.
Yep.
And tab. Yeah, that should be good. As far as I remember, I think we keep the return tabbed in from the function.
Yep.
Okay. So we want to fix that. Yeah, I think that it should work. Okay, cool.
So I guess just some little things now. I know you're doing the Python and C mix here.
Mhm.
But so just because that's already there, you have to reassign n here to cast it over.
Okay.
And then you don't need to say the data types. But other than that, I think you're good.
Okay.
Okay, so this should work. Do you know much about time and space complexity?
Yeah, a bit. I would say that this is, well, we go through n once. So I think it's a complexity of n linear.
Okay.
Okay.
And that's because we go through it once, you said?
Yes.
And then what is n, just so we're on the same page here?
Yeah, so n is the number of elements in your input. Like the number of elements that like the function will read through.
So the digits in the number?
Yeah, yeah.
Okay, yeah. And then space?
Space, I'm not as familiar with space. Is that like the memory that it takes up?
Yeah, so any additional space on order n that we are adding to it.
Okay.
It's on the same big O notation, but just now with the how much you're adding in order to get your solution.
So we made 3 additional variables. So I'm not sure how you would phrase that as far as space, but whatever the significance of adding 3 variables would be as far as memory.
Yeah, so it's going to be constant space. So basically, so say you added an array of size n, then it would be a space complexity of O of n because we have an entire array that is on order n, right?
Yeah. Mm-hmm.
All right, yeah, so this is good. So now, what if I said you can't do this cast here? And you have to keep it as an integer. How would you do this? So I'm going to go ahead and remove this line.
Okay, let's think. So we don't know how many integers n has. I mean, how many digits n has, but
right.
Maybe we can use some kind of like hotkey where you, well, no. I was thinking like you could create an array of ones and zeros where you could increment which element in that array of ones and zeros has a 1 in it, and then maybe like multiply that by the number and see which no, actually that doesn't work.
Right. I'll give you a hint here. So let's say our n is 1, 2, 3, 4, right?
Yeah.
So in order to traverse through this digit by digit, we basically want to extract the 4, then the 3, then the 2, right?
Yeah.
So in your loop here on line 15, how can you extract digits one at a time?
We could use some kind of powers of 10 maybe to expand it.
Yeah, no, you're on the right track there with the 10. So what operator will give us, so you said powers of 10. So if I, how can I extract powers of 10 from a number?
You could do,
So how can I get the remainder?
Oh, well, you can use a modulus to get the remainder of a number. Okay. Oh, so you could say like 1, 2, 3, 4 mod 1000 would give you 2, 3, 4. And then that remainder, like the 2, 3, 4, you would mod it by 100 to get 3, 4. So you continue to mod them until you suddenly have the 4. Well, that wouldn't give you the individual digits though.
Yeah, you're really close. So how can you do that backwards? Because remember, order doesn't matter, right? So because 4 plus 3 is the same as 3 plus 4. So if we just wanted to get this 4, then what do you mod this number by?
You would mod it by 1, 2, 3, 0. Like.
Yeah, or you could mod it by 10.
Oh, right. Okay. Yeah, okay. So
All right, so then, yeah, go ahead.
So if you modded by 10, then you would get the 4, and then you would use that digit. You could subtract 4 from 1, 2, 3, 4 to get 130, and then you mod that by, well, I'm trying to think how you would just get rid of the 4 completely.
Right, so when you do a mod, right, what's kind of happening there? So you do division and then it gives you the remainder?
Yeah.
So what if I just divided 1, 2, 3, 4 by 10?
Oh, right, and you would do that each time to
Yeah.
shrink the number. Oh, okay, that makes sense. All right, so I think I know where I want to go with this.
Okay.
Let's see, so for x and n, when we say x and n, that starts from the beginning, but with this approach, we want to start from the end of the number.
Right, so I think that the for loop might not be the best style here.
Okay.
Because right now for x and n, you can't do an in operator on an integer because n is an int. So remember that every time that we divide n, like you said, the number is going to shrink and keep shrinking until it's left with only 1 digit left. And that's probably going to be when we want to break out of it.
Okay, so we want a while loop then, right? So we could have some condition as when, like, while n is positive, or while n
Sure.
is 0. Okay.
Yeah, while n is greater than 0 works.
Oh, we don't need these. So while n is greater than 0, we'll put this into our while loop, and we don't need that anymore. So while n is positive, for x and n, get the product and the sum. Okay. So in addition to that, we... Wait, what was the purpose again of separating these numbers out? Sorry. Oh, you're saying that if an integer and not a string.
Right, so the for loop there won't work anymore, I don't think.
Okay.
So now how do you update product and how do you update sum? Or what I should say is, to start off, why don't we just extract the digit that we're trying to do the math on?
Okay, so while n is equal to greater than 0, we're going to want to come up with maybe like a temp.
Sure.
So this will give us 4. So we're going to want a for loop to do that for us so that we can get all the integers out.
So isn't that what the while loop can do, though?
Yes. Yeah, you're right. Yeah.
All right, so you got your digit. So now you just need to update your sum and product and then update n. And then I think we'll be all set.
And is product. Yeah. We need to update what we modded by, though. Or no, we don't. While n is greater than 0, we need to edit n in some way. So we're going to divide it by 10. Oh, right, we're going to divide it by 10 each time. So n equals n divided by 10.
Yeah.
Okay. Then results and return result.
Yeah, there you go.
Okay, cool. Yeah, I think that should do the job.
Yeah, no, that'll do it there. So it's basically the same thing you just had, but we avoid that cast. So now we can keep everything with the, the input data type. So now in this case, what about the complexities, the time and space?
So the complexity of this would be O of n again, I think, because you go over the data once. And then the space would be, again, constant because you're adding like a finite number of variables.
Yeah, good job. So the only thing is that in the time complexity here, some people could argue that this is O of log n. If I can type this right. And the reason would be, say n is, in this case, 120, 1, 2, 3, 4, then this is basically log base 10 of n because we only have to run through it 4 times, right? But that's why I asked you in the last one, like, what is n? And you said it's the length, so this is totally fine. I mean, these are equivalent, just the way that we explained it. So yeah, good job.
Thank you.
Do you have any questions?
I think I'm all set. Yeah, it all looks good. In a real interview, would you recommend creating a template so that it could be scaled to different kinds of applications, or would this be okay, like making it just for an integer?
Making like like you're saying in like the C++ world where you can have like a type name T or whatever that is?
Oh,
or
right.
Are you saying?
Yeah, so I guess it would only be applicable to C++ then, but in Python, it takes in any kind of type, right?
Yeah, and I mean, if you wanted to do a type check, then you can just do, type n int or something like that and pass out. But yeah, I mean, this is good. I think in terms of like in interviews and things, it's really important to write your function definition and then use some scratch space up here, just to kind of show your logic. So we have like a example here and stuff like that. But yeah, no, overall, good job. So we'll get going on the next question in just a second.
All right, sounds good.